In this video, in which we'll finish our coverage of Chapter 7's material, I'll teach you guys about electron affinities as well as some general properties of three different categories of elements: metals, nonmetals, and metalloids. Let's begin by discussing electron affinities. As I mentioned in an earlier video, an atom's first ionization energy is the amount of energy required to remove one electron from it, thereby forming a cation. For example, the first ionization of carbon is as follows. The positive delta E right here means that energy must be put into the atom or into this system or process to remove its electrons. In other words, it takes energy to remove an electron from solid carbon. Because this delta E has a positive sign, this process is endothermic. Now, in contrast with this example, most atoms can also gain electrons to become anions. The energy change of adding an electron to an atom is called an atom's electron affinity. Remember, affinity is a term that means how much you want something. I have a great affinity for that thing. If you're an element, affinity is a measure of how much you want an electron. So, for most elements, energy is given off when an electron is added. For example, adding an electron to sulfur gives off energy, as shown in this equation. We have elemental sulfur and add an electron to turn it into sulfide 1-. The delta E is negative 200 kJs per mole. This negative delta E value means that energy is given off during this process. Hence, this process is exothermic. Now, generally speaking, the more badly an element wants electrons, the more negative will be its electron affinity. Now we'll move into discussing metals, nonmetals, and metalloids. As you look at this periodic table, you can see that all of the gray-colored elements are metals, all of the blue-colored elements, which are largely to the right, as well as hydrogen, are nonmetals, and these ones that kind of traverse or sit on the fence in between the two that are colored purple are metalloids. I'm now going to tell you about properties of metals. Metals are shiny, malleable, which means they can be bent and then bent back. They don't crumble when you bend them. They're ductile, which means they can be drawn into wire, and they conduct heat and electricity. Elements show increasing metallic character as you go down and to the left on the periodic table. Metals have low first ionization energies. That is, they easily lose electrons to become positively charged cations. This means that metals like to be oxidized. They like to lose electrons. Transition metals, the ones in the D block, can often form ions with differing charges. For example, iron can exist as iron 2+ or iron 3+. When metals and nonmetals bond, they generally form ionic compounds. Most metal oxides are basic. That is, they react with water to form hydroxide salts like this. In this example, I've got sodium oxide. It reacts with water to form sodium hydroxide. Now we'll talk about the properties of nonmetals. Nonmetals can be solid, liquid, or gas. They're not lustrous, that is, they're not shiny, and are generally poor conductors of heat and electricity. When nonmetals bond with each other, they generally form molecular compounds, as opposed to ionic compounds that are formed when nonmetals bond with metals. Because they have larger negative electron affinities, which means they like electrons, nonmetals tend to gain electrons when they react with metals. That is, they steal those electrons from the metals. Most nonmetal oxides are acidic, which means they react with water to form acids, as seen in this equation. Carbon dioxide, and an example of a nonmetal molecular compound, reacts with water to form this molecule called carbonic acid. Now we'll discuss the properties of metalloids. Metalloids have properties that are somewhere in between those of metals and nonmetals. You can see on the periodic table, for example, that metalloids kind of straddle that in-between world that traverses metals and nonmetals. For example, silicon looks like a metal, but is not malleable. According to our text, several metals such as silicon are electrical semiconductors and are the principal elements used in integrated circuits in computer chips. One of the reasons that metalloids can be used for integrated circuits is that their electrical conductivity is intermediate or somewhere in between that of metals and nonmetals. Metals, for example, conduct electricity. Nonmetals do not conduct electricity. So metalloids kind of traverse that realm in between, which allows them to be semiconductors. Very pure silicon is an electrical insulator, which means that it prevents electricity from being conducted, but its conductivity can be dramatically increased by adding specific impurities called dopants. This modification, or this ability to just gradually or incrementally increase or decrease the conductivity of silicon, provides a mechanism for controlling electrical conductivity in circuits. Whew! With that said, that is the last lecture in Chapter 7. I hope it's been super fun for you. If you remember anything from this lecture, please remember that metals are shiny, and I like shiny things.